Good evening, everyone. Welcome to class. Greetings, everyone. Welcome to class.
Good evening, sir.
Good evening, sir.
Wonderful, wonderful, wonderful.
Good evening.
Blessings, 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 blessings. All right, Miss Grayson, for that request that you made last week, Miss Morgan gave me permission to do it for you. She says she's not going to, you know, get engaged in that as I had told you. So, as it relates to that, just come see me and let me see if I can help you with that document here. All right, and Samantha, I finished looking at your stuff, so I had sent you a voice note this morning.
Yes, sir. Yes, sir. I heard it.
So whenever you can just come and let me just give you the corrections in person, okay?
Okay, sir. Sir, what time will it be there tomorrow?
Oh, I'm there all day tomorrow, so I'm going to work early because I have to burn some this tomorrow. So,
Oh,
yeah. Hi, Sahenia.
okay.
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 All right.
I'll come
Lovely.
by.
Yeah, man. No problem. All right. Lovely, 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 lovely. All right. Wonderful. All right. Welcome to class, everybody. We are going to our final week of March. Well, technically next week Monday is our final class in March. So we have 3 more classes left in March, and then we are heading into that very intense month. Hope you like my motivation I gave you this morning about not giving up, right? Hope that you guys stay focused same way, and just like I promised you when I met you in September, that I was going to give you 110% right until the end. I am dedicated to doing just that. So me, I'm not gonna just battle it out. Remember that I owe you guys some hours. So don't forget. I won't forget. So don't forget that we'll be working when the school closes in. Well, I think the last class is going to be at 27th or the 28th because school closes on April 30th according to your contract. But because of Hurricane Melissa, you guys would have suffered more than the physical students. I'm going to be teaching you guys for an additional 4 days in the first week of May just to compensate you for some time. All right? So everybody can get equal total amount of hours. And as you guys would have known, that this weekend coming is going to be a lovely one. Make me so excited for the online class because I love teaching online so much. It's just one of my favorite things to do. So saddle up, guys. For those who are coming face to face, we start at 9. We start at 9:15 pretty much because we give persons time to come in. So if it's face to face, we start at 9 and we end at 4. So it's 6 hours of teaching. We'll be going through a past paper. I won't tell you the year. I'm not even sure yet, but we're going through a year. And then on Sunday morning again, we'll be doing the same thing. But you can either pay for the package, as I said, you can pay for the package where you pay, you have the post already, right? So you can pay the $3,000 extra for an additional 42 hours. Or you can just come face to face. You won't lose out. It's just that the more we repeat the same thing, is the better it's going to be for you. All right. So I'm looking forward to seeing. So some of you guys have never met you in person. So I'm looking forward to meeting some of you in person. All right. All right. So with that said, Miss Gentles, I see you just coming online. Where were we last week, Monday?
Bearings.
Lovely. All right. Did we go through the process of how to draw the bearing? Wait, let me see if I can find my old whiteboard. I wonder if I can find it back. Also, I don't have it. Oh, my boards. Hold on. Last week was when? Last week was the 18th?
Because we're doing the bearings for 16 on a Monday class. It was the 16th.
16th. All right. I'm not seeing it. Oh, must see this here. Okay, it's my board here. Open board. Latisha, you're not stop writing on my board? Okay, so this is
Not
what we
me
did.
this time, sir.
Oh, not you this time. All right. So, okay. So this is what we actually did. Now, so this is where we're at. Okay, lovely. And I hope that for those who missed the class would have checked out. Miss Gentles, you always keep up to date with me. Did I post last week's lessons already online?
Yes, sir. Yes, you did.
Okay, so I don't have any outstanding recordings for you guys then. All right, that's lovely. All right, then. So with that said, since this is where we're at, hold on. So we would have gone through the bearings fundamentals. Okay, lovely. So we're going to take on a question. That means tonight. So we're going to do
Sir?
one more. Yes, go ahead.
Sir, you gave us a question last week that you said we were supposed to try, but you were gonna go through it this
Oh, I
week.
did. I did. Did I?
Yes.
Okay. Was it? Okay, sure. We can go through that. Yeah.
There's
So
the question about the boats, two boats.
okay. Oh, okay. Oh, yeah.
Yeah.
I remember. And so we're gonna go through that now, and then I actually want to do a full question, and then I want to introduce circle theorem to you. All right, circle theorem, because we're heading to the end of trig. All right. So before we actually jump in that, I want to make a note of this. Let me just open my whiteboard. My bad. All right. So let us look at what we have left to teach. So currently we are on trig. So rest assured by next week, Monday, all our trig will be done. Right? Tonight and next week we should be finished with trig. So we are currently on functions and we're currently on trig. So that means we have these topics left. We have matrices left to teach. We have statistics. So we have matrices and vectors. They come together. Right? We have matrices and vectors left to teach. We have statistics and I think that's it. Yeah, I think that's it. I think that's all that we have left. Just matrices and vectors and statistics. We don't have nothing else to teach. So we only have those three topics because we're currently on functions right now. That's going to take us another 2 or 3 classes. So that should bring us to the first week in April. And then we're going to start vectors. All right, cool. So that's what we have left to teach. All right, so we're going to attack the question that I gave you guys to try. So for those of you who tried it and you get it right, we're going to see how it's done. All right, Golly, you can go ahead and read sentence by sentence for me.
Okay, sir. So the question is, two boats have decided to set sail from port A to port B and C, respectively.
All right, give me a sec. Let me just write that down. So the boat set sail from port. So read it one more time again.
So they set sail from port A, port B, and port C.
Set sail from port A to port B and C.
Yes, sir.
Okay, so it's moving from A
To
it's heading
B.
towards B and towards C. All right, cool.
Yes.
Continue.
And then it says port B is on a bearing of 260 degrees.
260 degrees, all right.
Yes. And port, sorry, I missed out a little part.
Anybody can help her?
Port C is on a bearing of 110 degrees.
110 degrees. Okay. Is there any distance that we're given?
No, sir.
So I didn't give you the
And-
distance.
No, you didn't. Then you said we are to draw a diagram to illustrate the direction traveled by the two boats.
All right, cool. All right, so we know that the boat is leaving from the same port. All right, so the first thing we need to is establish a position for A. So I'm gonna put my position right here. That's where my A is starting. I'm gonna go ahead. I'm gonna draw a north line at A.
Pardon, sir.
Pardon me?
The whiteboard isn't showing on my side, so I'm going to leave and come back.
Sure, no problem. All right, so I'm gonna
Yes,
put.
sir. Same for me too.
Yeah,
So
have
I'm
to
going
jump
to
out
leave
and
and
come.
come back also.
Yeah, okay. All right, so I'm gonna start with a north line here. All right, so that's my north. Because we know from last week we said that whenever the object is about to move, you have to establish a north line. So this is my A right here. All right, so this is A. Now the boat is leaving from A and heading towards B, but B is on a bearing of what? 260. So we need a couple of guidelines here. So we're going to use this guideline here. So we're going to use this guideline here. Give me a sec. So one guideline, this guideline takes us to what? 90. Hold on, let me just use it better. So this guideline is from to 90. So we can confirm that the ship is not going, the boat is not going in that direction. Another guideline takes us to 180. Oops. So this guideline takes us to 180. We know it's not going in that direction. And we need another guideline that takes us to what? 270. So we can confirm, here's what we can confirm. We know it's 260. So 260 is very close to 270. So I'm going to make an assumption that the boat is traveling somewhere in this direction here. Give me a sec. Let me just change the color. So somewhere in this direction. We don't know, probably suppose so. Right, so this is 270, you know? And in between here, draw it a little better. All right, so we know, say, in between here, so, is exactly 225. So we're going up, we're going up. I like it, this one. Yes. All right, somewhere there. So we know, say, it's not really accurate, but somewhere there. All right, so that is where the boat is going. Okay, so we know, say, it starts at A. So we know that A is right in the center here. So that's A. And we know that B is on this bearing. Now, how do we put on the bearing? Watch the blue line now that I'm going to use. So the bearing comes around like that. That is the bearing 260 degree. That blue line represents the curve. That's the whole entire bearing of 260. Now, here's what we're going to do, guys. We're going to put in these measurements from now. So we said it last class that whenever you start to draw the bearing, put in the degrees from now. So right away, I can safely say that this is going to be what? 90 right here, so. This again, I want next 90. And because we know, said the black line, this black line right here is 260. We know that if we take 180 from 260, we're going to end up with 80 degrees right here. So right here is 80 degrees. This is 80 degrees. Because you already have 180 down here, so. And then the rest of it here, so, is going to be carrying you to the 260. So we're going to say 180, and then 80 more degrees will take us to 260. All right. Lovely. So we know, say, right in here, so has to be 10 degree. Naturally, it has to be 10 degree. Because 260 plus 70 are going to make 260 plus 10 is going to make 270. So we can assume that that's what our first part of our diagram is. Now, that's one boat, you know. Now, it's not like the boat is moving from B now. The boat is moving again from A now. And according to what Galia told me earlier, is that Miss Gentles told me that the boat is now heading towards C from A, but on a bearing of 110. So let's grab another line again. So 110 now. Just a second, guys. My apologies, guys. I had to let somebody in the class. All right, so I'm back. So now we already have our north line already. We don't need another north line. Remember that the boat is leaving from A and heading towards B and C. So this boat is leaving from A, heading towards B, and it's leaving from A now and heading towards C. So C now is on a bearing of 110. So already we know that this is 90. So already we know that this is 90. We don't know so that a 90 already, right here. So we know it's not going in that direction. So therefore 110 has to be somewhere between here. Because if this is 90, then coming around a little bit more might be 110. So somewhere there. So it's not accurate. So somewhere there. Alright. Now because I didn't have any measurements, I don't know whether to leave the line short or make it long. I don't have any measurements. The idea of this was just to see if you guys could construct the diagram. So I'm gonna leave it right here. Okay. So where do I put the 110? Watch the blue line again. So the 110 now is going to be right here. Come around to that point. Right there, so it's 110. That is 110. Coming around. So a part of the 260 that we had, a part of it is 110 as well. So this little piece right in here, so that little piece there, because coming around to the red line right here is 90, then this little piece right here, so is going to be 20 in here. So let me zoom up. In here, so going to be 20 degrees. Because the 90 stop right here, so 90 plus what gives the remaining 110? That's going to be 20. All right. So technically, this is what your diagram would look like if you were to draw this thing here. And then you are going to just basically connect these two here to form the triangle. All right, so that would be your diagram. That's what it would look like. I'm not sure how many of you got close to that, but that is it. Okay, lovely. All right, so we've gone through the fundamentals. Now it's that Samantha got it right. So now it's time to actually do a question. Now it's time to do a question that, let's see how CXC structures it, right? So I want someone to pick a year and pick a month. The months are January and May, and I want somebody else to pick a year. We're just gonna do it random. Anybody?
Do we
No, man.
have a specific time frame for the year?
No, man. It's either January exam or May exam.
Okay, 2018.
2018. And somebody give me a January or May.
May.
All right, cool. No problem. All right, good. So we're gonna do. So you guys
Sir,
selected
someone
random.
is asking if we always have to draw the triangle. I was wondering too because I did it, but I didn't draw the triangle.
So most of the time, they always want you to complete it. So even if you didn't, if you got that close, it's still good. But always complete the journey.
Okay.
All right, as you will see. So you guys selected what? 2018 May randomly. I don't know what is on 2018 May, so we're gonna pick up that. All right, so I'm gonna end my whiteboard here and share my screen. I want you guys to screenshot this for me. No, I'm not gonna just take. Yeah, you can screenshot it. So here, Lord, hold on. You guys are not seeing my screen. Hold on, give me a sec. All right, you guys should be seeing my screen now. All right, so we're gonna head onto the website. We can find the paper. You guys said 2018 May. Let us see what comes up. Let us see if we can get a bearings question. All right, lovely. 2018 May. 2018 May. All the way up here. Here you go. Right here, so. So just a random question. Let us see if we can find a bearings. Let us see how CXC structures their paper. So we're scrolling down all the way to question 10. That's where you can find them. That's where the bearings is located. All right, scrolling down. Can we find a bearing? Can we find a bearing? Yes, we can. Look at that lovely question. Go ahead, guys, and screenshot that for me from your side. So I'm going to take a picture as well. Have you gotten that? Have you guys screenshotted the question from your side?
Yes, sir.
Okay, I'm gonna scroll down shortly. All right, so that is one question. How much marks did you do? 1. Okay, let's go down. That's the question. Go ahead, guys, and screenshot that one as well. That's it. That's 2. And that is 3 marks. So the whole entire question from that year was worth 6. And then, so this is the topic we're going to next. We're going to learn how to approach topics like those, all right? Lovely. So we have a 6 marks question. Everybody has the picture. I'm going to go back onto my whiteboard. And we're going to attack this question. And as you can rightly see here, guys, the diagram was already drawn for you. So I'll go on. The diagram was drawn for you already. All right. Let us see now. So I'm looking from my side. All right. Somebody can read for me. Go ahead. In fact, hold on. Yeah, while the person is reading, I'm gonna sketch by the diagram on the screen. So go ahead. Somebody, Sam, you can read. Or anybody. Hi, somebody can go ahead and read, guys.
Sir, I took the picture, but it's not clear, so
Want me to go back?
I'm not seeing all my words clear.
Anybody who took the picture or screenshot can see it?
Maybe I could read and then someone who have it clear could probably see what it is. But a diagram below, not drawn to scale, show the relative positions of 3.
Let me just go back and
I'm
do
not
some
sure what
persons.
is that.
It's all right. Let me
Yeah,
just go back
it's
and give
not
some
clear.
persons a chance.
It's not
Okay,
clear.
that's right. Some persons have never heard your voice in this class. It's so very difficult to really understand my students if you guys don't talk to me now. See, dear Miss Gentles, go ahead. It's the same voice I hear every week. But okay, all right, not doing anything. There it is, Miss G. Hold on, I'm gonna hit that. Hold on, see there. Some persons, I don't even know how you look. I don't know how you sound. I don't even know if you're learning or you're not learning. Can not talk to me, but okay. There it is. Can you see it now?
Sir, can to bring it up a little more.
Got it?
Yes.
Screenshot yet?
Yes, sir. I think it's a little better.
All right, there it is now. Can you see that section now? This one. Got it?
Yes.
Lovely. All right, now back to the whiteboard. I'm going to open a new whiteboard here. I'm confused myself. All right, so Miss G, you can go ahead. And in the meantime, while you're reading, I'm just going to sketch back the diagram.
Okay. The diagram below, not drawn to scale, shows the relative position of 3 reservoirs, B, F, and G, all on level ground. The distance, I think that is BF. I'm sure if
I think, yeah, it's B and F, yeah.
Yeah, BF.
Yes, 32 kilometers. FG, 55 kilometers. And I'm sure, BF equals 32. FG equals 55. And then is it greater than?
Yeah, leave out a part. Continue.
Kilometer? Yeah, you can say, because I'm not sure.
The BFG is 103 degree.
Okay. The bearing of what? The bearing of, the angle BFG.
Right.
Oh, yeah, I didn't say
think
that
that's
part.
what she was saying.
Okay,
Yes.
Right.
And
Gotcha.
the F is on a bearing of 0.42 degree
Okay.
from B.
Lovely. So this is 32 according to what they must say. this is what, 32. This here is 32 kilometers. And then so this is 55 right here, so 55 kilometers. And this is B. And just move this here. This is B. And this angle, them actually put, watch out, them put it all on the diagram for you. Hey, the people like, you know, and not putting it on phone, you know, now find that to yourself.
The angle is 100 and
F is right at the top of
F.
the
Okay.
103, 103.
Okay.
Yeah.
And then this
G
angle is
is
42. Who is writing on my board? Hey, Craig, I'm going to beat you up, youth. All right. And then G, the all the way out here, so. All right, let us see if we have everything now. So we have a north line. Oh, on this north line, you can see basically. Oh, Lord, watch out. Mercy. All right, so this is the diagram that you guys are looking at on the past paper. I didn't miss out anything, right? All right, so let me just run through it again. It says the diagram below, not drawn to scale, shows relative positions of 3 reservoirs. Obviously, the reservoirs are B, F, and G. And all on level ground. The distance, BF is 32, as you can see on the screen here. BF is 32, right? So it's 32. And FG is 55. You can see it right here. That's FG, 55. And then said the angle BFG, the angle that is at F. Remember that the angle is located at the letter that is in the middle, 103, which is on the diagram. And F, and then said the bearing, and then say, and F is on a bearing of 42 from B. So F, this F right up here, so is located 42 degrees away from B. All right, good. So for 1 mark, 1 mark is it worth? A 1 mark it worth? My hands are covered. A 1 mark? Them say determine the bearing of B from F. So they want the bearing
Yes, sir,
of B from F. So they want the bearing of B, but they want you to measure it from F. So if they're asking you for a bearing, ladies and gentlemen, you need to construct your own north line. Once they're asking you for the bearing, you have to then construct your own north line. So I'm going to construct a north line here. So they're asking you, they gave you the bearing, you know, of F from B. So they already drew this angle for you right here. But they're asking you for the bearing of B now, but you have to measure it from F. So I need a north line right here. And so what they want is, they want a bearing. Give me a sec. Hold on, guys. All right, so that's my north line. Let me just kind of move this F from here, so I'll put it more like right here. All right, good. Lovely. Okay. No, that's my north line. So what bearing do I need? I need the bearing coming all the way around. So look at what I'm doing here. I need the bearing coming all the way around here, including the 103. So I need all of this bearing right here, coming all the way around like that. That's what I need. I need all of that bearing. So I already have a portion of it. I need this portion right here. That's the bearing I need. Remember, bearing is measured in a clockwise direction, you know. So if I'm being asked to calculate the bearing of B from F, that means I need to come around in this direction here to complete the bearing. So I need this angle out here. So how am I going to find that now? Watch this. All right. Oh, okay.
180. 180.
Yes, it involves some 180 business, you know. Because you see, the thing is that I'm looking for an angle that is on the outside of the diagram. So I need to find this angle out. I need to find a way how to find that angle outside. So what I'm going to do, what should I go on now, you know? I'm figuring out which direction should I go. All right. All right, so look at this now, ladies and gentlemen. Look at this cheeky little way of getting to the answer. So remember that in there's 103 already. I'm just going to push it on the outside here. I'm going to say that's 103 here. Now watch this, guys. Look carefully. Look at what I'm going to do. So I have to find a way. I know that inside here so is 103, but I have to be cheeky to get to the answer. So look at this now. I'm going to just extend the line here. Look at it carefully. Look what I'm going to do. So I'm going to extend this line here and create a south line. And by creating a south line, watch the color that I'm going to use now. You see that? It's called a Z angle. That's called a Z angle. Look at that blue line that I just draw. Let me draw it again. North, sliding up like that, coming down to that south line. That is called a Z angle. So basically what that means then is that the angle in here is exactly equal to the angle right in here. Look at the Z. North, so. So the angle right here is equal to the angle here. So this piece of angle right in here, so a 42. Not true? And we know that from north to south, so what we know from north to south is what? 180. So that's 180 plus 42. So from north right here, come all the way to this south line that I've created is what? 180. We know that from before. North to south is 180. But because of that cheeky little method that I just used there, running north and coming down to south, it created a Z angle, which is 42. So this 180 that I have around here, along with the 42 that I just calculated, that's going to give me the full bearing there. Right. Sir, how would I know how to do that? It just takes experience. Over time, we learn to do these things. All right, so that is how we'd get that answer. So you can answer the question there by saying that angle. Sorry, you can answer the question by saying the bearing of B from F is 180 plus 42. And that angle is going to be equal to 222 degrees. You can give them a little reason. You can tell them that the angles are alternate. So you can see alternate angles. You don't have to do that. Alternate angles. So like the Z that you saw there. All right, so let me just put back like the Z for you so you catch it. North, slide up here, so come down to that extended south. That blue line forms the Z. So in this little piece here, so is 42. Remember that the 103 now is from this point all the way to over here. So we must say these two angles here, so it's them two angles here, adds up to 103. But because of the Z, we were able to take out 42 out of the 103. So question, can anybody tell me how would I find this little piece over here? How would I find this piece right over here? What would I do? If I need to find it, what would I do? If all of it is 103 and I've just cut out 42 out of it, what would I do to get the rest of the angle here? Anybody figure it out yet? How you got that, Galia?
Sir, I did subtraction.
Correct. Very good. So this piece right here, so would be, of course, Jenny, you can talk. So that's going to be 61 degrees. So 42 and 61 would give us the total of 103 that was given to us. So by those little construction lines, we were able to split up the 103 into pieces. Now, can anybody tell me how we'll get this outside piece if we need it? We don't need it now, you know. We answered the question already, you know. But just in case, how would we find that outside piece? What would you do? If the full angle come round, so now we know at 222. How much out of the 222 we have?
Take the 103 from it.
Very good, Miss Gentles. You're gonna take the 103 from the 222. So what would that outside angle be? We can find it from now.
119.
X 119?
Yes,
That's
sir.
it's on nothing, but all right. Yeah, man. Yeah, it's on right.
Wait, sir, 103 minus from 222?
Yeah.
Yeah, man, 119. Somebody can confirm that.
119 degrees. All right, just in case we need it. All right, we don't know if we're gonna need it, but we just find it just in case. All right. So you see how we break up those angles now? They only gave us 103, but we were cheeky enough to break up the 103 into two small portions. Next question. What was the next question on that you saw? The next screenshot. So we got 1 point there, sir. I'm looking at it. It says, can you confirm if it says calculate the distance BG to 1 dp?
No, I get that the question.
It was the second screenshot.
Sure, I never get that the shot there.
The gentles, can you confirm it?
Yes, sir. That's what it says.
So it says that you want us to calculate this distance.
The distance BG given your answer one decimal.
One decimal place, yeah.
Okay. Now, do we remember which rule do we use when we are given two sides and the angle between the two sides? What rule did we learn recently that spoke about giving two sides and the angle between?
I think it's a cosine.
Very good. Not think it is. So for part 2 now, we're going to say that using cosine rule. So like I told you at the beginning of bearings, you know, bearings is an application of everything that you've learned. So using cosine rule, what's the cosine rule? C squared is equal to A squared plus B squared minus 2AB times the cosine of the angle. Now remember that A and B is this side and that side. So that's going to be, we know say C is going to be the unknown in this case. 32. Guys, take out your calculator from now in the meantime. 32 squared. And then we're going to have plus 55 squared minus 2 times 32 times 55 times the cosine of 103. Because remember, say the 42 and the 61 give you the 103. You know? All right, so go ahead now and work out what is 32 squared plus 55 squared. We can work out that one time. Somebody can work out this part, and then somebody can work out another part. So somebody work out 32 squared plus 55 squared one time. (32 squared plus 55 squared). What's that?
4,049.
Yeah, that's what I got.
4,049. 4,049, very good. And then somebody has work out now -2 times 32 times 55 times the cosine of 103. You should get a positive answer.
I'm seeing 191.8.
How much you got?
You said
I didn't hear that.
-791.8.
791.8. If you get negative, you know, it's because you left off the negative out here. So remember, it's -2 times 32 times 55 times the cosine of 103. You should get 100. You should get a positive answer. All right, so go ahead now and add those two numbers for me. What is 4,049 plus 791.8?
$4,840.8.
4,840.8. And then now
Yes,
we just
sir.
know that once you want to find C, it's going to be equal to the square root of 4,840.8. I go ahead and find the square root of that, please. And we should get C. Well, in this case, we wouldn't be finding C. We'll obviously be finding what? BG.
70. You get
70 flat?
70. 69.5, so we just square it out to 70.
No, them say one decimal place, you know.
Oh,
So
69.5
69.5 or
it's B,
0.6.
or 0.6, right?
yeah, man, BG. All right, so your guys are correct. So BG, so it's BG squared here. So it's BG squared and then BG squared. Oh, sorry, BG, pardon me. And that's equal to how much is it? 69.6. All right, kilometers. That's it. So this distance here is 69.6 kilometers. Lovely. Fantastical. All right. And then now let's work on what was the last question? Can anybody see the last question?
I think you said calculate to the nearest BG, the bearing. Calculate to the nearest degree
The bearing of
of
G
G from
B. So remember now, they want the bearing of what? G, but they want if you measure it from what? B. Guess what, guys? We check it out already. Box cover. Back foot, guys, see the 119. You see me I talk about? We do it already. Because them say them want this bearing, you know, G, but you have to measure it from B. So we already have the knot line at B already. Oh, sorry, B. Lord of mercy. Sorry. Lord. Sorry, guys. Them say from B. Oh, so them want this bearing now. Stop here. Oh, you tired? Look so. So them want this bearing here, so. But we already have P side already 42, so all we need now
Yes,
P
sir.
side.
Just take that from 90.
No, we can't assume that. We can't assume that this is 90 because
It's
they didn't
90.
say that. Yeah, they didn't say that B and G.
Oh.
They didn't say that G is due east from B. They didn't say that.
Okay.
But after cosine rule, what did we learn? What formula did we learn? After we learned cosine rule.
Sine.
Sine rule, very good. So remember that they work hand in hand, you know. So as one do the work, the other one just follow right up. So what is the sine rule? Can somebody remind me? Check the notes. Is it small a over the sine of big A? I say go. Confirm it, please.
Yes, sir.
Thank you very much. So small a, right. So can anybody remind me of how I told you to use this formula? The small letters represent the side and the big letters represent the angle. So can somebody tell me how we discussed it? I think I told you to pick a side, call it A, then look in front of it to find big A. Something like that? Was it something like that? So pick a side and call it A.
No, it's from the angle.
All right. So can we do something now? So which side are you going to pick?
Pick the side with 55.
All right. So you're going to call this small A, right? That means that the angle you look for is big A. No, so?
Yes.
So which side are you going to pick for B now?
The side F.
The side in front of F, right? So you'll call this B and call that big B. Why you can't pick 32? Why you think we can't pick 32?
Because there's no angle.
Excellent answer. There's no angle in front of 32. And we don't even need it. We have to focus on what we're looking for. We don't have an angle in front of 32. So let's plug it in. 55, you guys watch the recording, you know. So now if you practice them something, you know. So 55 divided by the sine of what? 55 divided by the sine of The angle, we don't know it. We're going to call it theta. So we just call it theta right as well. And then that'll go equal to B now, which is 69.6. So you know, so if you get that wrong or you can't get it, your goose cook. If you get it wrong, your goose cook, roast. But if you know, all right, so let's go. So we know, so we can't work out nothing over here. So can you go over here and work out what is 69.6 divided by sin of 103?
Sir, is 69 you're using or the whole 103 minutes?
No, the angle 103.
Okay.
Yeah, man. The angle in front of it, 42 and 61 is 103. I have to go ahead and work out 69.6 divided by sin of 103.
$71.4.
How much?
71.4.
That's 71.4. All right, so anybody recalls what happens when the unknown is at the bottom? What do we do? Start with S.
Yes, swap.
Very good. All right, that can work as well. But Geneva, cross multiply and I'll give you too much work. So just swap. So you put the 55 over here and put 71.4 down here. And then that's equal to sine theta. For those who miss out on this class, the recording is already posted, so don't know if you guys missed out. So go ahead and divide 55 by 71.4, please.
Zero 0.77.
0.77.
Yes,
Give me
sir.
one more. Give me one more decimal place.
I'm seeing 0.770.
All right, thank you very much.
Okay.
So how we find the angle now? Anybody recall how we find the angle? Remember what button to press to get the angle? Start with S. Correct, Geneva.
What a
Shift.
shift. Yeah, yeah. Mhm.
So when you press shift and you press sign, what comes up on the screen is what? S-I-N minus 1.
So I get 50.38.
And that's your question. And you complete your past paper. Sorry, you complete the question. So how much you get? 50?
50.38.
50.38. And them said nearest degree, right? That's what the question said, nearest degree. So 50 degrees. That's it. And that's it.
Sorry, it look easier saying, but when you see the paper now is
I practice, man. I just practice, man.
Yeah, but so what me say, sir? Let's say we're doing the pairings and we attempt it, but not sure if we're on the right path. Do we get like a 1 mark or 2 mark?
Yeah, man. As long as you show that you have an idea of what you're doing, you're not gonna get full marks. Because if you recognize that you're to use the cosine rule, you attempt to write it, you're putting numbers, but you calculate it wrong. It's the marker knows that the student has an understanding of what to do, you know.
Oh.
You get marks for understanding, you just lose marks for comprehension.
That's true. That's true.
So you'll get marks for understanding the concepts needed to be applied. You get marks for reasoning out, which means it's the calculation, but you get marked down for computation because you calculated incorrectly.
Okay.
Yeah. So they're not looking necessarily for the answer, but you're looking to see if the student knows what formula to use on which question.
Oh, okay.
So what would be the total? Yeah. Go ahead.
No, that's all right. That's okay, sir.
Okay.
Sir, question.
Yes, question, Sam. Go.
Considering that both papers won't be on the same day, after we do paper 2, you keep class to do first paper 1?
Unless it's highly requested. Unless it's highly requested. So multiple choice and stuff.
Isn't paper 1 coming first? I think that's what I see.
No, man. Paper 2 is coming first. Paper 1 is in July.
So when is?
Hold on. What you say, sir?
Something.
Paper 1 will be in July? I thought it was May 28th.
Well, I don't know if the timetable change up, but then switched up. Normally it's in July.
No, it's about 2 weeks after.
2 weeks after, man. Yeah.
Oh, them change it up now. Okay.
One on the 12th and one on the 28th.
I have not seen the timetable. Just know said the first exam is the 12th. So.
Oh, okay.
All right, so you can make a note of that, guys, because these students sound like them sure. So, all I said, so the total bearing is going to be what? 92. So Miss Gentles, you see how close it was? Had you subtracted the 42 from 90, you'd have gotten 2 degrees short. So you saw the diagram almost drawn to scale. So you doing that you'd have gotten the 1 mark for the answer, or half a mark for close to the answer, but you'd have lost a lot of marks because you wouldn't have used the correct formula to get to the accurate results. All right, we're going to do another one. Let's do another one and wrap it up. I wanted to introduce circle theorem, but it's not a topic that I like to rush, so I'd rather do it next week, right? Where next week, Monday, I can start fresh. So shall we do another question like this one? Another bearing? Everybody okay with that?
Yes, sir.
All right, pick a year, pick another year, and pick another month. Make it January this time.
January 2017.
So it wasn't 2 pictures you asked us to take?
There were 2 pictures from the same exam paper. So the 2 pictures were the actual questions. For this, yeah, those are the parts of the question. All right, so 2017, pick something, come up closer to 2025 now, pick up something up this. So far, no one go? Okay, all right. No one go so far?
January 2023.
All right, Zoom user 2020, we never had an exam. That was the year of COVID, so no paper 2 was done that year.
What about question 9 that was on the same paper?
No, we just have focused on bearings tonight. Because question 9 is this question, but the other part of the question is circle theorem. I haven't taught you that as yet. Yeah. All right, so I didn't see anybody.
You asked us to take it as well. Sorry.
Oh, no, man, I asked you to take a picture of... Oh, you accident. Oh, I see what you're saying. No, man, we're not doing that. That was an accident. I get what you're saying. All right, so which year in the soul now, though? Talk to me. (2022), Craig said 2022. January or me? Let's do January. Zaina said 2022 too. Okay. So 2022 January. All right. Let's do that then. And that should take us to the end of the session. And then officially know that. Oh. And there's some other bearings question on my channel as well, you know. So I'll send Miss Gentles and she's going to send it in the group. So you can always watch my other bearings videos as well. They're good too. All right. So let us... So go ahead and take the screenshot of this question. 2022 January. Let's see what them send come that year there. 2022. 2022 January. There we are. As I tell you, bearings is something that comes. But when you start matrices, you guys probably are going to just dip on it about like this topic here. Because the moment you guys see matrices, we're not going to love it. It's always the go-to question for students. Them tell me I hit them like so. All right. So did they send anything for us? I'm sending the circle theorem first. All right, there it is. That's it. All right, there it is, the bearings. So go ahead, guys, and take that picture so you can read it back to me. Let me know when you're taking the picture.
Right here, so come and read that fast and you come to.
Take it.
Yes, sir.
Good. So that question is worth 3 points. All right. Take that part too. That one is worth 2. Calculate NR. The distance NR. Take it.
Mm-hmm.
And that's it. Oh, Lord Jesus, there's more. One more mark down this. So take that one too.
You said determine.
Yeah, that one there. So this question is worth 3, 2, 5, 6. So you can see, so far we just picked 2 random people, and you see that the bearings is worth 6 points on the exam. All right, now have that. Lovely.
Yes, sir. Run with it, sir. Run with it, yeah.
Run with it. New whiteboard? No, sir. Use what this. No, sir. More fresh whiteboard. Lovely. All right. So I'm going to read. So as you can see, once again, ladies and gentlemen, you notice how I taught you? Me teaching you how to draw the diagram. Them people are spoiling like brat. Them draw the diagram for you. Me not drawing it for you. I'm not going to draw it to myself. But since them like, no problem. I'm going to draw my north line. Them little people are loving them, man. So that's north. When I was doing math back in 2008, 2009, you have to draw this yourself. Oh, Mr. Peart. So something like so. So it looks something kind of tilt. Not fully 90 still, but it was something like so. And then was so. Try to draw it as accurate as I can, no guys. Well, how many look, guys? Am I right? My diagram can go on?
Yes, sir.
We can go on. Okay, we can go on.
Yes, we can go on.
All right. So this is M. This is N. This is L. This is R. This is 12 kilometer. This is 10 kilometer. This is 88 degree. This outside here is 50. First, I see that paper here. I don't really follow these past paper things unless I'm doing marathons. I really don't. And it's like sometimes by the time I remember that the past papers exist, it's like 2-3 years later. So most of the time I'm seeing this question for the first time. All right, there we go. So we're good to go here now. All right, good. So remember, guys, stop with yourself. We're pretending like we've seen it for the first time. We're not pretending. At first we see it. All right, good. All right, so we have, this is a 10, right? Look like 16, so my God. Lovely. All right. Remember, say it's a 12, All right, so somebody can help me. I like when time students and talk to me. Me now I'm 5. Somebody else can read. Anybody, it doesn't matter. One person.
Diagram below shows straight roads connecting the town L, M, N, and R.
All right, stick up in. Make sure you see them. You see the L, N, M, and R? As you read, make sure you can see them, L, M, N, and R. So basically those are roads, right? Continue. Continue.
LR equal 18 kilometer.
Check.
LN equal 12 kilometer.
Check.
And MN equal 10 kilometer.
Check. All three are check. We see them. Good. Continue.
Angle RLN equal 25 degrees.
Check. What that there? Right, that's all. Check. We see it.
Angle LMN equal 88.
Check. Right, that's how we check it. That's all. That's it. That's all them say?
Yeah.
All right, cool. So based on what they have told us there, we check everything. We see everything there. We see the 12, we see the 25, we see the 88, we see the angle, we see the measurements. The only thing that is there that they didn't spoke about is what? The 50 degree. So more than likely that's going to come into play. All right. So what was the first question they asked us to find? For 3 marks, calculate the angle MLN. Is that so? Calculate the angle MLN. Where the angle is there? That's the question. Where is that angle? Angle LMLN. So M to L to N, the angle here, which is this one right here. So we need to calculate that angle. Now we have to go decide now. Remember now, we are in a triangle that's not right angled. So you have to start, in this case now, you have to start decide who and who can help you and who can't help you. And who can help you, run them way. So who can help you? Pythagoras theorem cannot help you because you're not in a right angle triangle. Trig ratios cannot help you because you're not in a triangle. You're correct, Geneva. Trig ratios cannot help you because you're in a right angle triangle. You're not in a right angle triangle. And let's check now. So them two people, they can't help you. So run them way. So you have to look at cosine or sine rule. Correct, Zahenia? So is it cosine or sine rule? Well, let's check if cosine can help. According to the rules or the criteria, the scenarios of cosine, cosine states that you must be given two sides, which we have very clearly there. But with cosine says you have to have the angle between the two sides. Do we have the angle between the two sides, or do we just have an angle? We just have an angle. We don't have the angle between the two sides. Therefore, if trig can help, trig ratio can help you, Pythagoras can help you, cosine can help you, then it just seems that what Geneva and Zahenia said a while ago is that it's sine rule. So therefore, we have now is going to be, so we're going to end up with, answer the question MLN, we're going to say using what am I talking about? Cosine. Using sine rule. Sine rule is A over the sine of big A is equal to B over the sine of big B. Now, did you guys notice what I did there? I asked myself certain questions. I know who and who can help me where and where, you know. I know that Pythagoras theorem and the trig ratios, they work in the department of the right angle triangle. This diagram I'm looking at is not a right angle triangle. So me just know what I even think about them. Them can't help me. So me go over the other side and me ask cosine and sine rule. Which one only can help me? Cosine says I can help you if you can give me the angle between. You cannot give cosine the angle between, so therefore cosine says I cannot help you then. Check sine rule. Sine rule said, do you have two sides and an angle? You do. You have 10 and you have 12 and you have the angle. So him say yes, him can help you. So already now, pick a side, call it A, look in front of it, find big A. Tell me what you do. Pick a side, call it A. What you want to do? Come on, guys. What want to do? We said no one be A.
88
and
degree.
You want 80? Which one you want to be small A? Which side?
The 12.
Yeah, you can't wrong, you know. Yeah, you can't wrong. No matter what you do, you cannot be wrong. So this is small A, right? Yes. Any side you pick for A, you know, you cannot be wrong, you know. No care what you do, you cannot get it wrong. So this is small A. So that is big A. And then obviously this is B, and this is what? Small, big B. All right, lovely. So small A is going to be 12 divided by the sine of the angle in front of 12, which is 88. And that's B, which is 10, over the sine of the angle in front of 10 is the unknown angle. We don't know it. So go ahead now and go on the calculator. What is 12 divided by the sine of 88? On your calculator, please. What's 12 divided by the sine of 88?
12.0.
12. Oh, 12 same way?
Yes, sir.
Lord of mercy, what is this, though, Lord? All right, I'm not sure. Check, good enough.
12.00.
Okay, 12.00. So it's 12. All right. All right. And therefore, so we cannot divide 10 by an unknown quantity. Now, what do we do when the unknown is at the bottom? It starts with S. Geneva made a mistake earlier and said the wrong answer. Good. Swap. Correct. So we're going to swap. So you're going to put the sign up here. Put the sign up where the 12 is and put the 12 where the sign was. So 10 divided by 12. Go ahead. What's that answer? What's 10 divided by 12? 0 point something.
0.8.
Flat? 0.8? Okay. So how you find theta now? Hold on, with 0.8 what? 33?
Yes.
Oh, put on the 33, please.
It's recurring.
It's recurring. All right. So theta is equal to sine inverse 0.833. All right. So you press shift, you press sine, press that number. Bam. What's the answer?
I get 56.4.
So 56 degrees. That's it. So the angle right here is 56. All right. Let's clean up our diagram. Lovely. So that angle is 56. What's the next question? So that's done. Moving right along. All right. What's the next question? So that's 3 marks. Blow out them like, 3 marks. That's a lot.
You said to calculate the distance NR.
So MLN is done. That's 3 marks. Then say calculate the distance NR. NR, then, ladies and gentlemen. Down here, so? That's a NR, that's so? NR. All right, so talk to me. NR. Look at the triangle that has NR. What does it look like? 2 sides and the angle between who that? 2 sides and angle between who is that? Cosine. Very good, Geneva. Cosine. So cosine. Remember, I tell you, if you watch about the recording, I specifically told you that, you see, when you use cosine, follows up with sine. But if they make you use sine, follows up with cosine. So more than likely, if you use sine, then I'm going to try for force if you use cosine. It's just how Csec writes the question all the time, every time. All right, so now what is cosine rule? So cosine rule is cosine rule. Cosine rule says that this is, give me a sec. So cosine rule is c squared is equal to a squared plus b squared minus 2ab times the cosine of the angle. All right. So we know, so C now is the unknown side, which is NR. So it's NR squared is equal to 12 squared plus 18 squared minus 2 times 12 times 18 times the cosine of the angle, which is 25 degrees. So now NR squared is equal to, work out this one person and then somebody else work out that part over there. So Genevieve got 468. Somebody can confirm 12 squared plus 18 squared. She said she got 468.
It's right.
She's right. Okay. Somebody else go ahead and now multiply -2. Don't forget the negative, What is -2 times 12 times 18 times the cosine of 25? How much you guys got? -2 times 12 times 18 times the cosine of 25. How much you got? Doesn't take so long. We are
negative 21.75.
How much? I didn't hear that.
Hold on. Let's go something.
Negative 391.5.
No, I'm sorry. I didn't hear that. You were echoing.
Negative 391.5.
0.5. Okay. Subtract
That's
those
what I
two.
got.
Okay. So subtract those two.
$76.5.
How much? Oh, 76.5. All right. So therefore, NR is equal to the square root of that thing. Okay.
$8.74.
Did they give any instruction? Did they say 1 dp or anything? Okay, so it is how much? 8 point how much?
74.
So 8.7 is fine. So whenever them don't ask you to give it to a 1 decimal place or 2 decimal place, it means that you should round it off to 1 dp. Unless them tell us a 2 dp or a whole number, then round it off to 1 decimal place. That's it. Nice. Juicy marks. All right. And next question. Last question before we get out of here. What was the last question? There was another one. Was that it? But there was one more, man. I didn't take the picture apparently. Them said bearing of something from something.
Determine the bearing
R of tone L.
Say that again.
Determine the bearing of tone R from
tone R from tone L.
Yes, sir.
Make sure say it's from L, you know. From L, it's right?
Yes, sir.
And then it's easy. Just add the 50 and the 56, so you're done. That's it. They want this bearing, so they want to know the location of R. They want to know the location of R. Make sure me understand this here. So they want to know the location of this thing here, but them say must measure it from what? L. We already have a knot line at L, so the bearing will come all the way around here, so. So add up the 56, the 50, and the 25. You're done. That's it. End of story.
From R to L.
Yeah, you're measuring it from L, you know. So you have to draw one arrow. So if you're measuring it from L, look at it. If you're measuring it from L, the bearing is going to come from naught. It's going to come around like that. It'll go past what? M. It'll go past what? R. Past what? Sorry, N. And come around to what? L. So it's all of those three numbers there. 50 plus 50. Oh, so that's why the 50 was sitting there. And we never use it. No. We realize how the 50 come in now. They gave us the 25. And they said that they gave us the 25. We calculated the 56, but notice that the 50 is sitting there how long and we never use it. So that's where the 50 comes into play now. So the answer is going to be R from L is equal to 50 plus 56 plus 25. That works out to be 106, 126, 131 degrees. All right, and that is it. Perfecto. So, ladies and gentlemen, this is what them call bearings. For some, it might be the hardest thing you ever do in your life. Whilst for some, it might be, oh, I'm finally getting an understanding of this, but it's going to require practice. Remember, we're going to have several of these in the month to come. So you're going to see this again and again and again and again and again, 7 times or 8 more times. All right. So this brings us to the penultimate topic in trigonometry. Next week, we will be going into circle theorem. All right. And then, of course, on Wednesday, we're going to continue with our functions. Hopefully by mid-April, we'll be able to start matrices and vectors. And we'll also be able to start statistics as well. All right. But that is
what is so we're doing next week, sir?
Oh, next week, Monday, circle theorem.
Oh.
So we're gonna. So for those who don't know what circle theorem is, let me show you. For those of you who do know what that is. All right. Circle theorem. So this is what we them call circle theorem. So circle theorem attaches itself to bearings. All right, so let me just scroll down here. So circle theorem is this thing down here. So that's up here. This here. So if you notice where it comes with geometry and trigonometry. It's question 9 on the paper. So if you scroll down, you can see that it attaches itself to what? To bearings. So bearings is part B. So sometimes them send bearings first, then them send the circle after, or then put the circle first, then the bearings after. So if you're going to attack question 9 on the exam, you're going to have an understanding of bearings and circle theorem. Or else if I don't teach a circle theorem and you attempt question 9, you're only going to get half the mark. All right. So ladies and gentlemen, with that said, if you have no questions or queries, I'll see you guys on Wednesday. Until then, be safe. Have a good night.
Good night, sir.
Good night, sir.
Thank you, sir. Thank you very much.
Good night.
Good night.
And good night. Good night to you as well.
Anybody going to what do you call it, something, export documents? Okay. Yes, somebody said it, sir.
Good night.
Yes, Craig. I'll go on, Craig.
So I know the SBA is due, but because